Okay, now let's look at this functions. Now we done this in the fifth class statement, right? Now let's look at this as functions. Now functions are actually data type independent in Python. Okay, what does a function does is that, let's say you have a certain data, a certain set of codes that you want executed again and again and again throughout the program. Okay, throughout the program. But instead of repeating the but with different input arguments. Okay, or the same or different types. Okay, now but the fact is, the problem is, okay, instead of writing, I may have to write the commands, write the entire statement, repeating statement again and again and again and again throughout my program, wherever I need it. What if I just write this in some kind of under some banner or some name, and I call this so that all this group of statements gets updated again and again. Now that's how functions that's where functions are helpful. Now if I were to run this, okay, if I were to run this factorial thing again and again and again, I have to call this, right, print the statement again, and I have to make corrections here and there. Instead, I can do the same thing in functions. Okay, how do I do it? It's like this. Okay, you need a function name. Okay, and to define a function, you need to use this keyword called as def space def is used for defining the function. This is the function name, and within brackets you write all the variables that you want the function to take as input arguments. Okay. Here the factorial function needs n as the input argument. Okay, and now everything else is the same as we saw in the previous if statement, and what's the only thing that is different is return f. Okay, now since you have, so what this is return f does is that this function is going to give as output some other value, and this means that this function gives a value, and that value can be assigned to some other variable. So how do we call it and how do you use it? It's like this. Since this function returns a value, put on the left hand side put a variable and set it equal to like this, and on the right hand side put the function name and enter and pass an argument into it. Simple as that. Okay, simple as that. Now let's copy this and execute this in the statement over here. Okay, let me run this out. Okay, now this is the command that's being executed. This is being done over here. Okay, let me enter a value like 7. Okay, let 7 first say. It says that execution or else the value of 7 factorial is 5040, and then it prints 5040. This 5040 gets printed because of this, whereas all the statement execution or else and value of 7 factorial everything gets done over here. Now if you want to do a new operation like now if you want to find a factorial for some other number, I don't have to do all this process. All I have to do is that I just have to call the value something like a equals fact of, let's say I'm giving a value like I just want to calculate the factorial of 10. Okay, press enter. It just says the factorial of 10 is value of 10 factorial is this much. This is it. Not bad, huh? Now like that, if I want to do a certain operation like this and all, if you want to do the factorial every time like this, now you don't have to copy this entire function. Once you defined it, just invoke it here and there. Now this is much better when compared to executing this entire set of statement again and again and again. This is much better. Okay, that's about that. Okay, and if you just want a function such that you don't have to return any value but just calculate the option, it's again possible. What do you do? Just copy all this, print it here, and then let me rename this as fact1 and cut this return statement off. Okay, now let me run this, copy this, and then run this selection control line. Okay, now if you want to calculate fact1 of say 4, okay, enter. That's it. Now this function, now there's a stark difference between these two functions. this function returns a value, whereas this function does not return a value. It just does some operation and that's it. Whereas this function does some operation and returns a value. So this is a function with takes input and does some returning operation, whereas this function takes input, does not return anything, like that. Similarly, you can have functions such that it does not take any input arguments, but give out output arguments. Okay, and same way you can have functions that does not take any input arguments, does not give any output arguments, like that. You can play around with that. Okay, and that's about functions. That's like a simple explanation. But good thing about function in Python is that they're like data type independent. Okay, the code needs to have a proper data. I mean, the code execution needs some understanding of what's data you're using. But for building up of the code, you don't have to worry about the data set. So if you want to return a data, you can return any kind of data. So let's say if you want to return integer, character, float, string, logical variable, tuple, list, arrays, dictionary, anything. It doesn't matter. You can return literally anything. And not only that, you can return multiple values along with it. Not just single value, you can return multiple values along with it. But when you return multiple values, you need to use certain unpacking mechanism to get the values out. We'll talk about this later. Okay, and also functions can return object handles, file handles, and everything also, depending on the case. And now with that functions getting over, let's look at slicing and also a little bit of modules, and with this we'll stop for today. Now what the slicing does is that it's just a convenient and efficient way of handling arrays. Okay, let's say you have a big array like this. Okay, and if you want to just pick out only select few values of an array, slicing is helpful. Now that's what the meaning literally comprises of. You don't have to use all the values. You just want just a small part of it. So you just cut out a small part of it, or slice a small part of an array, and that is what you do over here. That's what slicing does. Okay. Now let me give you this an example. Let's say you have a matrix like list. A is a list of values 0 to 10 in steps of 1. Okay. If you print A, it will print out all the entries. If you print A, this is how the result will get. Okay. If you print A of 7, remember 7 is actually the 8th entry in this list, because indexing in Python goes from 0, so 7 is actually the 8th entry, so it prints 7. If you print A of 7, it prints 7. So if you print A with a colon, it's just same as this. It'll just print everything, all the entries. Okay. Now if I want to print only select entries, like only from 6th to the 9th entry, I should print A 6:10. What it does is that it prints all the values from the 6th entry to the 9th entry. This 10 indicates, this 10 it will not print 10th. It will not print 10th entry, but the entry one below that, one less than that. So that's how you have to keep in mind. Okay, it will not, this 6 to 10 will not print all the entries, but it will just print one entry less than the on the right hand side. So this will print 6, 7, 8, 9 over here, and print A 0 to 4 will print all the entries from 0 to the 0th entry to the 3rd entry. Okay, or if you call it 0th entry, that is. Okay, and if you want to print all the entries from the 5th entry till the end of the matrix or the list, okay, you just print 5, colon, and that's it. You don't have to enter the value here. It's understood by the compiler that we are printing, the user is asking it to print the 5th value till the end of it. Similarly, if you want all the entries from the beginning till the 6th entry, you use this operation, A colon 7. What it does is just prints all the entries from the beginning till the, okay, I wrote it 7th entry, yeah, as 7th entry, but don't worry, it's actually till the 6th index, 7 or else 6th index over here. Okay, so let me run this. Let me copy all this code, and if I were to compile this over here, copy this over here, and I run this current line, I'm going to get the same document, same thing over here. same thing, same results over here. Okay, that's about it. And then that's about slicing. And note that these entries in Python also have negative. Okay, I don't not mean negative entries, I mean negative indices. Python, the elements in lists, tuples and numpy arrays also have negative indices. Okay, so that will be a little interesting. So you guys check about that, it will be interesting, and it may not be of much use for at least scientific computation, but for other people it will be really useful. And if you know what, if you use the negative indices also, sometimes some of your problems might be made much simpler. Okay, so it's worth to have a look at that. Okay, now that's about that. And then slicing, and then last topic for today is how to introduce modules or libraries. Okay. Now what these modules are actually a lot of files, lot of library files that you have in Python, inbuilt or user built or attached to the Python libraries, attached to the Python code. What they do is that they have a collection of functions, classes, objects, and objects and all, and even variables. Okay, and they add certain feature to and they add certain functionality to your Python codes. Okay, for instance, you have a lot of packages like you have a lot of packages. Okay, for scientific computation, some of the primary packages are NumPy, SciPy, and Matplotlib. Okay, NumPy stands for numerical Python, which actually is useful for generating scientific data arrays and other similar processes relevant to array handling and all. SciPy or scientific Python has a lot of scientific tools and mathematical tools inbuilt into them that are used for scientific computation. Matplotlib is actually matrix plotting library, something of that sort. Literally, what it actually means is that Matplotlib has a lot of classes, objects, and functions that are defined for plotting variables and contents, variables, values as graphs and charts and plots. Okay. These are some of the libraries. There are several others modules and modules. Okay. Now, what you'll do is that if you want to include these files, okay, you have to include these files as modules. Okay. To include them, there are a few syntaxes given. Now, if you to import them, you need this line called as import. Now, if I just type import NumPy, what it means is that it will import the entire NumPy library into the file. So all the functions, objects, classes, everything in this library module has, all this library has, all of them are included in the form of a NumPy module. Okay. Now that's one way. But if I include this way, for every function, I have to use NumPy. If I want to access every function or module inside Python, I have to use NumPy dot. If I have to use like NumPy dot this, NumPy dot that, like that. Now let me give you guys a demo. Let me copy all this. Let me paste this. Okay, let me paste this one after the other. So okay, as of now ignore these. Okay, now let me import NumPy. Now if I run this, okay, now what I do, if I just type NumPy and press enter, it shows that it's a module. Now if I want to access arrays, what I have to do is a NumPy dot array, like that. I have to access like that. Now that's one. So if I want to access arrays, I have to use like NumPy dot like that. On the other hand, if I just call array, you can't access it because array is not a part of this module, NumPy module. It's not separate. Whereas it's a part of the NumPy module, so it doesn't work. Okay. Another thing to do is that instead of importing NumPy as a module, you can import all the functions and some functions, class, and everything directly without importing NumPy as a module. And that is how you do. That's why you need this statement: from NumPy import star. What it does is that from NumPy it imports everything everything. Now if I look for array, okay, array or everything, all of them are available over here. Now this is okay, but this is okay for small modules and functions, but if you have a very large number of modules and everything, this becomes a little picky, little difficult. And that's why, okay, and now here in this option you have to include the numpy as module. So if for every function or class you want to access, you have to use numpy dot this, numpy dot that, and go on. And here if you use this, you don't have to use numpy dot everything here, but but all the functions are imported. But what if I just want to be picky and I just want to import only a few stuff, that can be done using this kind of a formatting. I use this. I want let's say I want a certain class or a function or a variable from a library, like I want this class from matplotlib library. What if only this, not the entire thing, only this. Now what I can do is that I can just write from matplotlib import pyplot. Now what this will do is that it will just import this pyplot class or object or function alone from this matplotlib. Instead of loading the entire thing, it will just upload this. Okay, and if you want to access anything that is a part of this pyplot, you have to use pyplot dot this, pyplot dot that, and all like that. Okay, similarly, okay, instead of, suppose let's say you don't want to use the function name like this or the module name like this, okay, you want to give another alternate name to it. It can be given as by this statement as like that. Now this np will be the short form of numpy in this entire module when you use it. Okay, this imports the module with the alternate name for convenience. That is it, nothing more. And also you can import specific parts of the other functions, specific parts of the other libraries using this import statement as well. Like import matplotlib.pyplot as plt. What it does is that from the matplotlib library, okay, it goes to all the files and finds this pyplot class in it, and then imports this within the file as with an alternate name plt. So this imports a specific function or class or library or variable from the given library with an alternate name as plt. That's it. Now another way of doing this is that you can write it like this: from matplotlib import pyplot as plt. This is just an alternate representation. Okay, now like that you can, like that, these are the possible ways to import libraries and functions in Python. And these are very, very helpful and essential when you guys go with advanced computation. Now that's all I have for you guys in this tutorial. Now in the next tutorial, okay, since I'm going with that, okay, let me give you guys an exercise. You don't have to solve this, but just have a look at it. Okay, there are two exercise problems over here. Okay, I'll just walk you guys through what you have to do. The first problem is kind of easy. Okay, find the 12 Fibonacci numbers. Okay, take the first Fibonacci number to be 0, or the 0th Fibonacci number to be 0, and the first Fibonacci number to be 1, and then find up to 12 terms of the Fibonacci number. These are all just explanation for you guys if you don't know what Fibonacci number is, and that's it. And now the thing is, the catch here is, use numpy arrays to do all this calculation. Do this using list and tuples if you guys want to experiment with it. It's not a problem. And when you use numpy arrays, set the value to be int 8. Now remember if I remember, okay, remember the numpy arrays thing over here. If you want to set the data type, you have to set the data type to be like this, like that. In the exercises, what I'm saying is that set the data type of these matrices to be int 8, and then run the program to see if and you might notice something peculiar over there. See what's happening, and then set that data type to be int 16 and repeat the entire thing. Do you notice anything strange? And if try to understand what's going on, and next tutorial I'll explain you guys as to what exactly is happening over here. And then that's about the first problem. If you guys want to know about what's going on, pause the video, see this. And then the second problem is a little bit harder, meaning what you have to do is that you have a vertical profile. This is kind of a little bit of a scientific thing, You don't have to worry too much about the details. I'll just tell you guys what you have to do. You have a, let's say you have an altitude profile and RH, relative humidity profile. Okay, meaning you have a sensor. As it goes up, it measures the height at different locations from a particular point, and then it goes up, and then at every point it calculates the relative humidity and gives the value in percentage like this. For every corresponding altitude in kilometer, it gives the relative humidity in percentage. Okay, now what is required of you is that calculate these values like es, e, t for all the values of z, for all the points. Calculate es, e, temperature, pressure, density, and everything. And the formulation, the how to calculate this is given by the formula nearby, and all the constants that are being used over in this entire thing are given nearby in these things. Okay, this is kind of a typical atmospheric thermodynamics problem, but it kind of helps you guys to do a little bit of job. Okay, you guys see how you guys just try and attempt this to solve this, and in the next tutorial I'll show with the code on as to how to solve this, and I'll explain you guys what to do and all. Well, this tutorial is kind of long. I'll stop it over here, and with the in the next tutorial we'll see how to solve this, and we'll slowly start looking at the plotting and extracting data from other files and all. Okay, in the next session we'll be in the next few videos we'll be looking at extracting data from text files, saving data to text files, extracting data from netcdf files, reading and saving data from matrix files, one-dimensional, two-dimensional plotting, and different plot enhancement processes. Okay, that's all I have for you guys in this tutorial. Thank you guys for watching, and I'll see you guys next tutorial.